Pete Smith is Professor of Soils and Global Change at the Institute of Biological and Environmental Sciences at the University of Aberdeen and Science Director of the Scottish Climate Change Centre of Expertise. And I know him very well from IPCC meetings. He's played a considerable role in the IPCC. And if I may just say that one thing I remember Pete for was at the 25th anniversary of the IPCC, he was a member of a group singing parody of YMCA. You just changed the letters to IPCC, and it was very amusing and very entertaining. So anyway, with that, I will pass over to Pete to talk about nature-based solutions on land.
Great, thank you, David, and thanks for the introduction. And thanks also to Gabby for giving that excellent introduction this morning to the science of climate change, the physical science basis. Now, as Gabby mentioned, she works mainly in Working Group 1, which establishes the physical science basis of climate change. I mainly work with Working Group 3, which is working in the solution space. That's what we can do to mitigate climate change. So I'll just share my screen. What I'm going to be doing today, I could talk about all sorts of things in that space, but I'm going to be talking today about nature-based solutions to climate change in particular. And I've focused on those partly because that's the area of work that I mainly work in, and partly because it's going to be one of the focus areas for the UK government in COP26. So the nature-based solutions are going to feature quite strongly. Okay, so I'm going to talk about nature-based solutions. I'm going to be focusing on the ones on land. But as I'll mention again or throughout the talk, not all the nature-based solutions that we know are on land. There are some in the ocean and in the coastal zone as well. And I'm not dismissing those. I'm just going to focus on the ones on land because land is the area that we most frequently manage. So why are we interested in nature-based solutions, and what does it mean, and how can they contribute to net zero? So if we look at the red line, if we look at the yellow line at the top of this slide, this is the business as usual emissions. So if we did nothing about climate change, if we had no climate policy, we will probably peak at somewhere around 70 gigatons of CO2 equivalents per year by mid-century, and we would then start to decline. That doesn't give us any chance of tackling climate change. That puts on our trajectory for at least a 3 or 4 degree rise in temperature, which is just which would be extremely dangerous, and that's not a future that we want to go for. So what we got to try and do is we got to get below 2 degrees. Or even better, below 1.5 degrees, which goes somewhere below this red line, to reach net zero emissions at some stage this year. For a 1.5 degree world, we need to achieve net zero in 2050. So you can imagine this red line coming down much more quickly to zero. Now, the reason we need some greenhouse gas removal is because this blue line shows what we can do with conventional abatement technologies. So these are things like switching to more renewables, using some more nuclear maybe, and basically decarbonising all sectors of society. So that's including switching to electric vehicles, using heat pumps instead of gas, and all those sorts of things, the things that we tend to hear a lot about. The trouble is, even if we reduce those as aggressively and as rapidly as possible, there are still going to be some emitting technologies in the mix. If we still want to continue to fly, it's likely that there will be some emissions from aviation, even if we reduce them quite significantly. Now, there may be advances in hydrogen or biofuels that will help with that, but we're still going to have some in the mix. But the biggest one that we're going to have in the mix still is agriculture. We have to produce food to feed everybody, and that necessarily emits greenhouse gas emissions, particularly methane and particularly nitrous oxide. So we're going to have some greenhouse gas emissions in the mix, even if we abate greenhouse gas emissions in just about all sectors. So the fact that we've got some greenhouse gas emissions in the mix means that we need some negative emissions or some greenhouse gas removal to offset this block of pink emissions. So this is where carbon removal technologies, so-called CDR or greenhouse gas removal or negative emissions, lots of different names for the same set of technologies. That's where these come in. Because if we've still got some emissions in the mix, we need to offset those so that we can get to net zero emissions. That's why it's called net zero greenhouse gas emissions. Now, these carbon removal technologies can be technological, or they can be based on land-based interventions, as I'll explain on the next slide. But what that allows us to do is offset these emissions so that we can get to net zero emissions by 2050. Our target in the UK is to get to net zero by 2050. In Scotland, our target is to get to net zero even more aggressively by 2045. And that will involve ramping up our nature-based solutions in particular. So greenhouse gas removal technologies can be categorized in a number of ways, but they fall into these sort of broad categories. So there are the technological solutions, for example, direct air capture. There are methods to capture carbon directly from the air to then pump that CO2 underground into geological storage reservoirs. So direct air capture is a technological measure which doesn't really use nature. The problem is with that is that it's quite expensive, both economically and in terms of the energy required to capture that carbon and to pump it underground. There are others, such as enhanced weathering, which we've got a greenhouse gas demonstrator project working on that at the moment. This is another one where you react minerals that naturally absorb CO2, you grind them up very small and you spread them on soils and they absorb CO2 and mineralize that carbon where it's stored for many tens of thousands of years. And ocean alkalinity enhancement and CO2 into durable products are some other examples of technological solutions. On the other side are the ones that I'm going to focus on today, the natural climate solutions. For example, planting more trees, afforestation or reforestation. When a tree grows, it takes CO2 out of the atmosphere by photosynthesis and fixes that carbon into the biomass and into the soil. So that is a biological store of carbon which can be there for decades or centuries. So this is a sort of a way of taking CO2 out of the atmosphere. Others are soil carbon sequestration, changing the land management so that we better manage the land, so that we get more soil organic matter, and that takes CO2 out of the atmosphere more or less in the same way as afforestation, reforestation. And we've got things like the use of biochar and restoration of peatlands or wetlands, which are high carbon density, and we can restore those to anaerobic conditions to store carbon in the future. And in the middle, one that I'm not going to talk about much today, are ones that have a combined natural and technological part to them. So there's bioenergy with carbon capture and storage. We grow energy, we grow crops, we grow biomass like trees or miscanthus, which is an energy crop. We harvest it and then we burn it for energy. So we use that energy in place of fossil fuels. And then we also capture the CO2 when we pump it back underground. So that gives you a net removal of CO2 from the atmosphere into geological storage and yields some energy at the same time. That's a controversial technology, and that's not one that I'm going to focus on today. Generally speaking, the technological options store carbon quite securely, so they're less vulnerable to reversal. Then at lower technology readiness levels, so there are greater research and development needs, and they tend to be more costly, both economically and usually in terms of energy as well. So these are the downsides of technological solutions, although you tend to store carbon for a long time. It's relatively secure. On the other hand, natural solutions are less costly. They're closer to deployment. We've been planting trees for millennia, so we know how to do that. We know how to manage our soils differently. We know how to restore wetlands and peatlands. but the carbon that we store in it is more vulnerable to reversal, as we've seen in the Californian wildfires. A lot of forests that were planted specifically to take up carbon have gone up in smoke and released that carbon back to the atmosphere. So there's this risk of reversal with natural solutions, but they are less costly and closer to deployment. Now, some of the natural solutions that I've mentioned already have been assessed for their potential to remove carbon from the atmosphere. And this is a study by Bronson Griscom and colleagues, which looked at the what the cumulative potential is for each of these natural climate solutions. So we've got things like interventions in the forest sector, such as reforestation, avoided forest conversion, natural forest management. We see they have a very large potential. We've got options in agriculture and grassland, and we've got options in wetlands and peatlands. When you add all these together, you've got a technical potential of offsetting about 25 to 30% of all the greenhouse gases that we emit. Now, I mentioned that that's a technical potential. Maybe the low-cost options are much lower than those, the ones that we can affordably use. And there are also risks associated with just going down the line of these natural climate solutions at the expense of rapid and aggressive emission abatement in all other sectors. Really, we should think of natural climate solutions as the thing that we do when we've done all of the greenhouse gas mitigation we can, and we just use these nature-based solutions or these natural climate solutions as the way to mop up any of those emissions that we can't abate. But not all of these land-based solutions, not all of these natural climate solutions or these land-based solutions qualify as nature-based solutions, and I'll explain why in a moment. That's because these land-based greenhouse gas removal strategies can be not very good for biodiversity and not very good for sustaining rural livelihoods. So nature-based solutions at the base of nature-based solutions is they have to have a measurable benefit to biodiversity, and they also have to have the full consent and buy-in of local communities and indigenous communities. So to qualify as a nature-based solution, you have to have climate change mitigation benefits, adaptation benefits, support local and sustainable livelihoods, and have a measurable benefit to biodiversity. Let's take, for example, afforestation, which is good for greenhouse gas removal. If you implemented that by planting production forestry, and we need production forestry, but let's just take that as an example. We plant vast areas of Sitka spruce, which is not very good for local biodiversity. It's not an indigenous species, not a native tree species here. And the biodiversity that it supports is much less than native broadleaves and in Scotland, the native pines that we have here, Scots pine and juniper, for example. So by planting native species, we could potentially be delivering reforestation as a nature-based solution. But if we implement it in other ways, for example, by planting large areas of non-native production forestry, which is bad for biodiversity, that wouldn't qualify as a nature-based solution. So where possible, we should implement our carbon dioxide removal options in a way that also constitutes nature-based solutions. So it has biodiversity at its base. It can be categorized, these nature-based solutions, into those that protect existing high carbon and high biodiversity stores, that restore those that have been degraded, so our degraded forests and degraded peatlands. 80% of our peatlands have been degraded in the UK, so they can be restored to their former glory, which would be great for biodiversity and also good for the climate. Improved management, because we've got a lot of managed land for agriculture and for production forestry. By improving the management, we can increase the carbon stocks and also benefit biodiversity. And we can create new and innovative ecosystems, nature-based solutions. For example, by putting in urban settings, we can use vegetation on the outside of buildings to provide cooling and to provide shelter. And elsewhere within urban environments, we can create artificial ecosystems that perform these functions that are good for biodiversity and good for the climate. But all of these, as well as supporting biodiversity, has to work with people. So it has to work with people and work with nature. And if we achieve these as a nature-based solutions, we get a bunch of co-benefits that are delivered just for free. So we get greenhouse gas reduction, we get flood and erosion control, coastal defense, cooling and shading, cultural capital, social capital, food and water security, and livelihoods. So all of these can contribute to sustainable development, human well-being, and biodiversity. So we really have to make sure when we're intervening on the land that we have all these things in mind, because we can implement them in a poor way, which wouldn't deliver to all of these options, but with just a bit more thought and planning, we can deliver them in ways that also provide all these other co-benefits. So how do we assess which of these solutions also offer co-benefits? I'll give you a couple of examples. So this is an example with reforestation. So I'll take you through it. It's a bit of a complicated diagram, but I'll take you through it so that it's easy to understand. So we have the afforestation or reforestation in the middle. In the inner ring of the pizza, we can define the functions that are provided by reforestation. So these are things like carbon sequestration, production of food and timber, fuels and timber, regulation of water services and air quality. It's a habitat for biodiversity. It can create jobs. It can create a space for recreation. So these are some of the functions that are provided by woodlands or afforestation and reforestation. What we can then do is we can map these functions onto the ecosystem services that we want to be delivered. So ecosystem services, or categorized here as nature's contribution to people, are things like habitat creation and maintenance, pollination, regulation of air quality, regulation of climate. And this goes around and we have 18 nature's contributions to people. Now, each of these functions contributes to a number of ecosystem services, as shown by these little green circles on the middle ring of the pizza. So where you see, for example, habitat creation and maintenance, number 1 on the middle ring is contributed to by functions 2, 3, 4, and 6, corresponding to these functions provided by the woodland. Having established what ecosystem services are supported by reforestation, we can then look at how these contribute to the Sustainable Development Goals. And there are 17 United Nations Sustainable Development Goals. For example, number 1 is end poverty in all forms everywhere. Number 2 is end hunger, achieve food security, and improve nutrition and provide sustainable agriculture, and so on. So what we can do is we can map the ecosystem services onto the co-delivery of these Sustainable Development Goals. So in the outer ring of the pizza, you can see the small circles here correspond to ecosystem services that have been provided by afforestation. So what you can see is that by following this little framework of looking at functions, ecosystem services, and then the Sustainable Development Goals, we can work out how an intervention will contribute to each of these. So afforestation or reforestation in particular is mostly positive, and that has positive impacts on most nature's contributions to people or ecosystem services and most SDGs. However, there are variable impacts on food and feed, and on the ecosystem services food and feed, and on the Sustainable Development Goal number 2, zero hunger, because large areas of afforestation competes with land for food production. But it can reduce land degradation and so can improve yields. So this is a variable impact. It can help on the one hand with food production by reducing erosion. On the other hand, it could occupy land that we otherwise need for food production. And reduced deforestation could have some negative impacts locally on economic growth for those areas, particularly in developing countries, which are using deforestation as a form of exploiting forests for economic development. I should say unsustainably, but it will have local negative economic impacts. If we look at another example, soil carbon sequestration, we can look at the functions provided by soil carbon sequestration. We can look at the impact that this has on nature's contributions to people or ecosystem services, and then we can map those onto sustainable development goals. Now, with this example, soil carbon sequestration, all the impacts are entirely positive. There are no negative impacts on ecosystem services or on the sustainable development goals for which there is data. So this shows that there are a few options which you can do, they're so-called no-brainers, which by improving soil carbon sequestration, we co-deliver to just about all of our other societal goals, as well as sequestering carbon and helping with climate change. But there are others which have to be implemented more carefully. So let's just bring it down to what we can do in the UK. So what nature-based solutions can we implement in the UK? So if we have a look at, for example, cropland management, forest management, management of grazing lands and grasslands, restoration of peatlands or protection of peatlands, we can protect our current woodlands and permanent grasslands and peatlands. Those are in good condition because they provide a large carbon stock which we want to keep in the ground and we don't want to have in the atmosphere. We can restore degraded peatlands. As I mentioned, 80% are degraded. Our forest and coastal and marine systems, so that's the so-called blue carbon areas, so we can restore the degraded ones of those and also contribute towards climate mitigation and support biodiversity. We can better manage our woodlands and soils, and we can create new woodland with native trees. By 2030, this could deliver between 75 and 123 megatons of CO2 equivalents per year, and that would be a significant contribution to our achieving our net zero targets. And by 2050, that could be round about 280 to nearly 500 megatons of CO2 by 2050. So quite a significant potential there for nature-based solutions to contribute to our net zero targets in the UK. Protecting carbon stocks in peatlands, woodlands and permanent grasslands would be a great thing to do. So the existing land carbon sinks in the UK total over 16,000 megatons of CO2. So that's a huge amount of carbon, and that's carbon that we want to stay in the ground and in the vegetation rather than in the atmosphere. When we assess those, 85% of those existing carbon-rich habitats deliver biodiversity benefits, and a further 15% have mixed or context-specific nature benefits. So, for example, some of our permanent grasslands are overgrazed, which aren't so good for biodiversity, but if they were in good condition, they would be good for biodiversity. So largely, we can protect these systems, we can improve the management in some cases, but we can co-deliver to nature enhancement, biodiversity enhancement, and also to carbon sequestration. We can also restore, manage, and create new woodland, and about 40% of these actions constitute nature-based solutions, and the remaining 54% could enhance biodiversity if implemented carefully. So this is my last slide. The land can't do it all. There's not enough land to soak up emissions from all of the other sectors that we have, transport, energy generation, aviation, etc. So we really do need to focus on aggressive and immediate action across all sectors of the economy. Not all greenhouse gas removal options on land are nature-based solutions, as I mentioned. Most of them can be, and they can contribute significantly to ecosystem services and the SDGs if implemented appropriately. But if poorly implemented, they could do harm to biodiversity, ecosystem services, and implement the Sustainable Development Goals. So it's not what you do, it's the way that you do it. So if implemented carefully, nature-based solutions are good for biodiversity, good for people, and good for both climate change adaptation and mitigation. But not all, and I'll just finish by reiterating again that not all nature-based solutions are land-based. There are ocean-based approaches as well, but these are comparatively under-researched, so we need more work in that area.